Hello viewers, my name is Mr. Kazim and I am delighted to welcome you to my YouTube channel at Smart Edu TV. Here you will find detailed tutorials on your science courses and tips on how to answer examination questions successfully. I started this channel to also share my knowledge and experience in this field and to give you tips on how to succeed as a university student. If you are looking for detailed tutorials on physics subjects, chemistry, mathematics, biology, statistics, and the general studies (GST), then you have come to the right channel. So therefore, sit back, relax, and join me on this journey. Don't forget to hit the subscribe button and turn on the notification bell to never miss on an important update. Please remember to also share this video so that others can benefit. Thank you very much. Okay, welcome back. So the next we are going to be looking at under complex number is multiplication of complex number. We want to see how we multiply complex numbers together. But for us to understand this better, it should be noted that anytime we are multiplying in complex number, I multiplying I. Anytime I is multiplying I is the same thing as what? I squared. And in complex number, I squared gives -1. This gives -1. This is standard. Anytime we are multiplying in complex number, I squared always gives -1. So please let's take note of this. For example, if we are told to evaluate if, let's say, S is defined as 3I minus 7, or let's say 3 minus 7I. S is defined as 3 minus 7I. And we have another letter, let's say H, defined as 5 plus 6I. 5 plus 6I. Don't forget, it contains two parts. The first part, which is the part that is not containing I, and the second part, which is the part containing I. This part is the real part, while the part containing I is the imaginary part. We want to multiply this together. This will give us the multiplication of S and H gives S multiplying H gives 3 minus 7I multiplying 5 plus 6I. 3 minus 7I multiplying 5 plus 6I. If we evaluate this, 3 multiplying 5 gives us 15. This gives 15. Also, 3 multiplying plus 6I gives 18I. So we have plus 18I. Also, minus 7I multiplying 5. We are going to have minus 35I. Also, minus 7I multiplying plus 6I. Minus times plus gives minus. 7 times 6 gives 42. Gives 42. Also, I multiplying another I gives I squared. And I squared is -1. Is that correct? So if I evaluate this, this will give me, I'm going to have 15 plus 18I minus 35I minus times minus gives us plus. So we have plus 42. So here I'm going to what? Combine them together, that is the real part together with the what? Real part, and also the imaginary part together with the imaginary part. For the real part, I'm adding 15 and 42. If I add that together, that will give me 57. So for the real part, I'm having 57. This gives 57. So let's look at the imaginary part. I'm having plus 18I, I'm owing minus 35I. If I pay my debt, I'm going to owe. I'm owing how much? What is 35 minus 18? 35 minus 18. This gives us 17. 17i. This is the result of the multiplication. 57 minus 17i. Welcome back to my channel. So the next we are going to look at under complex number is to look at solving equations involving complex number. How do we solve equations that involve what? Complex number. For example, if we are told to simplify 4 plus 5i equals z minus 1 minus I. We are told to solve 4 plus 5i equals z minus into 1 minus I. Solution. So please, let's take note. Under complex number, this z is defined as x plus iy. This is standard. Z is defined as what? X plus iy. Please take note of this. Z is defined as what? X plus what? Iy. Where x is what? The real part, and the y is the what? The imaginary part. So in solving this, let's write them very well. We are going to have 4 plus 5i equals z. Instead of writing z, I'll replace z by this. X plus iy minus what? 1 minus I. So the next thing, let's open up the what? Bracket. That is 4 plus 5i equals x plus iy minus and 1 becomes what? Minus 1. Then minus times minus becomes what? Plus I. Plus I. So that this can also be written as 4 plus 5i equals. So I want to what? Collect like terms in such a way that the real parts are classed together and also the imaginary part are also classed together. For the real part, there are those parts that doesn't contain I, which is x and minus 1. So I'm having x with minus 1, and also for the imaginary part, there are those parts that contains what? I. So plus I into what? Y plus 1. Since I factorized out I, so I'm having y here, I'm left with what? 1 here. So at the end of the day, I've been able to separate them in such a way that I have the real part and I also have the what? Imaginary part. Now, for us to solve, it means we are going to what? Compare the both sides of the equation. We are comparing both the left hand side and the right hand side. Comparing in terms of what? Comparing in terms of the real part and also comparing in terms of the imaginary part. Real goes for real, imaginary goes for imaginary. What are we trying to say? What are we trying to say? So let's look at this. So comparing what? These two sides of the what? Equation. Let me start with the real. I want to compare the what? The real part. The real part is that part that doesn't contain I. Let's start with the left hand side. This is the left hand side before the equal to, and after the equal to, I have the right hand side. On the left hand side, what part is not containing I? Only 4 that doesn't contain I. I'm having 4 equal to. On the right hand side, what part is not containing I? I'm having x minus 1. X minus 1. So 4 equals x minus 1. If 4 equals x minus 1, if minus 1 goes to the other side, this implies that the value of x equals to what? 4 plus 1, which is what? 5. I've gotten the value of x to be what? 5. Similarly, comparing the what? The imaginary parts. I want to compare the imaginary part. Let's start again. The imaginary part is that part that contains I. Let's start with the left hand side. The part that contains I is 5. On the left hand side, I'm having what? 5 equal to. On the right hand side, what is the quotient of I on the right hand side? The quotient of I is what? Y plus 1. Y plus 1. If 5 equals y plus 1, it means to get the value of y, this plus 1 can go to the other side, becoming what? Negative. It implies that what? The value of y equals to what? 5 minus 1, which is what? 4. 5 minus 1, which is what? 4. So this is how we what? Solve equation that involves complex number. Don't forget, we compare real for real, imaginary for imaginary. So the next, we are going to look at, after understanding how to use complex number in solving equations, so we are now going to look at the next concept, which is the concept of Argand diagram. What do we mean by Argand diagram? Argand diagram is simply the representation of complex number. How we represent complex number on the plane. That is what we mean by Argand diagram. Argand diagram. It deals with the representation of complex number on plane. That is on the XY plane. So let's look at Argand diagram. So this deals with what? The representation of what? Of the complex number on the XY plane or on the complex plane. For example, if you are told to represent z equals 3 plus 2i, z equals 3 plus 2i, using Argand diagram. How can I represent z, which is defined as 3 plus 2i, using what? Argand diagram. It simply means that I want to represent this function 3 plus what? 2i on the xy plane. And don't forget, for what? For our Argand diagram, the standard plane is the one that is written as, this is our what? Our real part. And this is our what? Imaginary part. The real part is the part that corresponds to the what? To the x-axis. While the imaginary part is the part that corresponds to the what? Y-axis. Now, how to represent this on the what? XY plane. The real part, that is, when the value of x is what? 3, the value of y is what? Positive 2. When x is 3, let's assume this is what? This is the origin, 0. When x is 3, let's assume 3 is what? Here. When x is 3, the value of y is what? Positive 2. We are going to have positive 2. Let's assume here is what? Positive 2. They met around what? This point. So this is what? So this shows the Argand diagram for z equal to what? 3 plus 2i. So this is what? This point is point z, which is equal to what? 3 plus 2i. So this is how we what? Draw Argand diagram. It's only what? Represents our real part and the imaginary part on the what? XY plane. What if we are told to represent, if we want to represent 4 minus 5i, if k equals 4 minus 5i, how can we represent this? How can we represent this using what? Argand diagram. This is also very simple. My real part is 4 and my imaginary part is what? Minus 5. It means on my x-axis I'm having 4 and on my y-axis I'm having what? Negative 5. What are we trying to say? This is my x-axis and this is my what? Y-axis. This is my what? Origin. Why is this going down? It's going down because on my y-axis I'm having what? Negative. Anything from 0 downwards becomes what? Negative. So on this part, on the real part, I'm having what? Positive 4. Let's assume here is what? Positive 4. For the imaginary part, this is minus 1, minus 2. Let's assume here is what? Minus 5. So they met around what? This point. So these are what? These are points on the what? XY plane. The point that represents what? Point K, which is defined as what? 4 minus 5i. So this is how it what? Represents a given function on an XY plane. Thank you very much.